Hi folks, so this is question 8. So it starts off with a scatter graph. So you just have to plot the points G and H. So G is 30, 40. So 30 is the city and 40 is the motorway. So we have to go to 30 along the axis that has city. So that's the x-axis in this case. So we're looking down here, and 40 on the other one then on the motorway axis, so it's where those two cross then or meet, so you can see that they meet here. So that's the dot for the first one, that's for G, and then for H it's 17 and 30. So 17 would, this here would be 15, so therefore 17 would be approximately here, and then you don't have to put in those workings by the way, but it's just to show. And then 30 is here, so it's where those two meet, so approximately there. So that's the 2 points plotted. That's the first part. Second part, draw the line of best fit. So line of best fit is the line that best represents the dots, so it goes basically right through the middle of the dots. So you need to use a ruler as well for this. So I can't use a ruler here, but it should be kind of right through the middle of them, like that. That might be a little bit low even. That's the second part done. Two other cars then, K and L, have the miles per gallon values given in the following table. So use your line of best fit to fill in an estimate for each of the two missing values. So for K then, the city part is 20. So therefore if I go to 20, which is here, and then if I draw a line up, and you must use the line of best fit then for estimating. So if I draw it up to the line of best fit and then across, it's about, we'll say 29, so you'll be given a little bit either way here, but that's about 29 then on the motorway axis or on the y-axis. So we do it the other way around then for L, because for L the motorway is given to us already, so that's 60. So if I go to 60 on the motorway axis and then I go across, my line of best fit isn't really going far enough even. So if I go across and then down, so that's about halfway on that box, and then I draw my line down. So you should really do all this with a ruler. So we'll say maybe 47 there. So you might get slightly different answers when you use a ruler, so it should be more accurate. Right, the next part then asks you, which would you be more confident in your estimate for? So would you be more confident have an estimated K or L? So the thing to see here is your estimate for the first one. So for K, it was right in here. It was where you, so that, see the way that's kind of in where the dots are. So that's, but out here then for the second one, for L, it's a kind of out here where there's no dots. So for all we know, the dots could have started going this way. Okay, we're not sure. But for the first one, it was very clear that the dots are exactly there and our line of best fit has to go right through there. So you'd have more confidence in the first one in K. And reason maybe no dots where you estimated the second one, where I estimated not the second one, I should say what it is, it's L. Okay, so where I estimated L. So something like that for a reason. Find the value of R, the correlation coefficient between city and motorway miles per gallon. Okay, so use the values for the 8 cars A to H in the table on the previous page. So for this part then, you need to use calculator. So there's a way of inputting all the data from the table up here. So you're basically going to put this in. So you're going to press on the calculator, you're going to press mode and then go down and press 2 for the table, and then 2 again for linear, and you're just inputting 2 columns X and Y, and then you're just going to put in all the values in the table. So they want us to use A to H, so you're going to put in all those values, and then we press equals, and then that kind of stores the table for you. And then I'm going through this quickly now, but yeah, you want to find the correlation coefficient then, so you're going to press shift and stat, and then choose 5, and then choose R after that, and then that should give us the correlation coefficient. So it might be a little bit different on some calculators, but that's generally what we're doing, is all calculator work here. So you should get 0.966 when you round it off. And they wanted it rounded off to 3 decimal places. So that's all of the part A. So there's 5 little bits in that. Right. So for part B, then it's just asking us a reason here. So it's a reason why you might think that the correlation coefficient is very close to 0. So it's because it doesn't really work for quadratic function, or quadratic kind of on a scatter graph. So the way you get R is from X divided by Y, really. So it's because it's linear, or sorry, because it's not linear. So it's closely where does it yeah, so it's closely approximated by a quadratic function. So that's the reason, really. It's because it's not possible. So it has to be very close to 0. Right. So for part C, then, so they give us 13 numbers, and they tell us what the mean of them is, and they tell us what the median is, but they don't tell us what 2 of them are. So S and M. So these 2 here. So we must use the fact we know what the mean is and the median is to figure them out. So if you were to add all of those numbers up there, apart from the S and the M, obviously, because you don't know what they are, you'd get 534. So the way you get the mean, anyways, you add all the numbers and you divide by how many there is. So 534 will be divided by 13 because there's 13 numbers, but you must add on S and M there as well. So that would all have to be equal to 52, because it tells us that the mean is 52. Then you can use algebra then. So if you move over the 13 and multiply it, and then you take away the 554, so if you move over to 554 then and subtract it, so you're just using 2 steps of algebra there, you should get 142. So 142 has to be what S plus M is. Okay, so if you think about it just from this, so this is just with the mean then. If you think about it just with that, the maximum you can get anyway, these are percentages, I think, they're all the scores, yeah, so it's score out of 100, it tells us up here in the question. The maximum you could get from that then has to be 100, because you can't get any more than 100. And the minimum it could be from that is just the 42, because it has to be more than 42 then to make up 142. So that's kind of the max or the minimum for S or M then. Well, for S really is what we're looking for. If you look at the median, so if you're to put all of those numbers in order, apart from the S and the M again, you'd get 24, 28, 30, 42, 46, 50, 54, 57, 61, 68, and 74. So that's all of them in order, but obviously you've got the S and the M as well that you need to put into that list somewhere. Now it tells us that the median, in the question it told us that the median was 54. So we know that the median is 54, and in our list, median is middle, by the way. That's what you need to know first of all, anyway. So the median is the middle number, so 54 is there. So if you think about it, then there's 1, 2, 3, 4, 5, 6 numbers already there. Remember, there's 13 in the list altogether, including S and M. Now 54 is the median, so if 54 is the median, there has to be 6 to the left and 6 to the right of it. So therefore S and M have to be on the right hand side here. So S and M have to be basically in there somewhere, or maybe further up than 74. So they have to be to the right hand side of that 54 anyway. So we know that much. And so if you think about it then, if you think about what the smallest number S could be, then just thinking about the median, like for example, if it was 54, it wouldn't work, because I think it said earlier in the question that no two scores were the same, so it can't be 54 because of that bit there. No two scores were the same. So if it can't be 54, if it was 53 for example, it would actually change what the median is, so we can't have it change because we know that the median is 54, so it has to be 55. So, well, or it doesn't have to be, that's the lowest it could be. So that's the lowest S could be. So the minimum of S equals 55. Now that's just taking into account the median. For the mean to work, the lowest it could have been was 42, but that means that's gone then, because if it was 42 or anything less than 55, then that would have changed the median. So it needs to satisfy both of them. So 55 or more would satisfy the mean to be that and the median to be that. The mean to be 52 and the median to be 54. So we know the minimum of S has to be 55. So let's go back up to what we kind of figured out in the mean part. We know that this S plus M is 142. So if you sub in 55 in for one of them, so 55 plus M equals 142, and then you bring over the 55, so M has to be 87. So S and M, really what we need to understand is that they're just kind of interchangeable here. It doesn't really matter which one is S and which one is M throughout the question. So therefore the maximum that S could be, so max of S would be 87. It couldn't be anything higher than that, because then it would change what the mean is and what the median is. So 55 for the minimum and 87 for the maximum. So that's final answer. So right, so for part D then, so these are just the probabilities that things could happen to his car, so that the head gasket blows, the timing belt goes, or air filters break. So they're all just bad things that could happen to your car. Right, so we have to use expected probability then. So you have to choose between him replacing it now or not replacing it now. So replace now or not replace now. So we're going to work out the expected cost then. So if if he replaces it now, so there will still be a probability that it blows again, but it'll be much less, obviously. So the probability then would be just 0.005. So if you place it now, then the probability of it blowing would be 0.005. So there wouldn't be much probability because it's basically, well, it's new then. So we must times that by 20,000. So that would be the kind of estimate cost then, but we must add on then the price of replacing it. Yeah, so if it's replaced now, it costs 1450. So that we have to add that on then, so 1450. So that's the probability that it blows then, even if it's replaced, it still has that probability of blowing after, even though there's a new one in it. We times that by the cost of it altogether if it did blow, and then we add on the cost of actually replacing it right now. And then if you do all that, you should get 1550 euro. Not replacing it now is more straightforward. It's just going to be the 0.095. So a good bit higher probability then, and just times by the 20,000. Because that's what it would cost if it does blow now, or if it blows at any stage. So if you work that out, then you get 1,900. So you can see clearly enough there, he should replace it now. So he should replace now. And that's your conclusion then, because it's much less. The kind of overall expected kind of money to pay is less by 400 euro. So for the second part then, it's asking us, so the probability that at least one of the events in the table above happens to his car this year. Okay, so taking these events to be independent. So if we look back up at the probabilities first of all, anyway, so probability of the head gasket, that's 0.095. So what we're going to work out is the probabilities. So that's the probability that they do blow. So we're going to work out the probability that they don't blow, and then we're going to do one, take away all of those. So the probability that that one doesn't blow then would be 0.905. I'll write them down here actually. So 0.905, that's for the head gasket. So I'm just taking these each away from 1, so I'm doing 1 minus 0.095. Then I do 1 minus 0.041 for the timing belt, and you should get 0.959. And then you do 1 take away 0.073, and you get 0.927. So that's the probability that they do break, that they do go, or they do break for each one. Then what we're going to do is we're going to multiply each of them together. So I'm going to times them together, and then that would be the probability that something goes, basically. So that probability that something does go or something does break, and then we can do 1 take away that. So I think when you multiply each of them, then you're going to get 0.8045. That's rounded off, and then what you do is, because that's the probability that something breaks on it, that's one of those three things will break, and therefore you want the opposite of that. So you want the probability this is the probability that they don't break. Sorry, I'm confused. That they don't break. So then we do 1 take away that, and that's the probability then that the one does break, that at least one breaks. So we get 0.195. And then that's rounded to 3 decimal places. So that's everything then for that question.